video is going to focus on respiration and the physiology of the respiratory system. So we're going to start with pulmonary ventilation, which is what we all call breathing. It consists of a repetitive cycle. It is one cycle of inspiration and expiration, which we're going to define. The respiratory cycle is one complete inspiration and expiration. There's two types of respiration. Quiet is while we're at rest and is automatic. We don't have to think about it or try. And forced respiration is the deep, rapid breathing that we have during exercise. So all of this breathing is based on a pressure gradient. And the book gets very detailed about this, so we're going to be less detailed about it. But it is what guides the whole process. So the flow of air in and out of the lung does depend on this pressure gradient. Remember, that just means an area of high pressure and an area of lower pressure between the air within the lungs and outside the body. And that pressure gradient is actually shifts depending on if we're inhaling or exhaling. The muscles of the breathing change the lung volume and create the difference in air pressure relative to the atmosphere. So we not only change the pressure, but the volume changes as well, and that has to do with those muscles. Again, I would encourage you to watch these animations. You need to be in presenter view, or you can always just find them on YouTube separately. Let's talk about those respiratory muscles first. The diaphragm is the prime mover of respiration. It contracts to flatten, and when that happens, it enlarges the thoracic cavity, and that helps to enlarge the whole volume of the lungs, and it does pull air into the lungs, but that has to do with the pressure as well. And then when the diaphragm relaxes, it goes upwards, and it compresses the lungs and pushes the air out. The diaphragm contraction and relaxation accounts for 2/3 of the airflow. So without that muscle, our breathing would not be what it is. But there's also some help that come from the internal and external intercostal muscles, which you learned about in A&P 1, I hope. They are located between the ribs, and they help the diaphragm. They act as a synergist to the diaphragm. This kind of talks about all of the contributions, but as long as you know that it helps out the diaphragm, I'm good. And it does add about 1/3 of the air that ventilates the lungs. This talks about some accessory muscles that help in forced respiration. We're going to focus on quiet respiration for now, but just realize when you are doing those extremely deep breaths that there are some accessory muscles, more than just the diaphragm and intercostals. So normal quiet expiration is an energy-saving passive process, and it's based on the elasticity of the lungs. And as the muscles relax, the structures recoil to their original shape and smaller size of the thoracic cavity. So we're going to talk both about pressure and that volume, but the volume getting smaller absolutely does push the air out of the lungs. This talks about, a lot of us don't even think about it, but we do at times take a real deep breath and hold it, and then we contract our abdominal muscles to help raise the pressure and push organ contents out. We see this in childbirth, defecation, urination, and even vomiting. So that's just showing you respiratory muscles, really beyond the diaphragm and the intercostals. I don't need you to go into too much more depth about the muscles. So we're going to talk about the automatic and unconscious cycle of breathing first, and kind of what is controlling that. It is controlled by 3 pairs of respiratory centers in the medulla oblongata and in the pons. And these 3 groups all have abbreviations. We're going to talk about the primary one first, and then the secondary and tertiary, or the other 2, just briefly. So in the medulla, we see our primary generator of that rhythm, and that just means how we have that respiration that's so automatic we don't think about it. It's involuntary, and that is coming from primarily the ventral respiratory group, and we're going to call that the VRG. So these neurons, there's eye neurons called inspiratory neurons, and they fire every 2 seconds, or about 2 seconds, and that is beginning the inspiration, and then the E neurons are called expiratory neurons, and they fire for about 3 seconds, allowing the other I neurons to relax, or I muscles, excuse me. And so this working together, going back and forth, produces a rhythm of about 12 breaths per minute. So that's the primary way that our breathing is controlled. Okay, but there's also some times that we don't just need that quiet respiration. We don't have just a normal respiratory rhythm, and that's where these other two come in. So the dorsal respiratory group, or the DRG, does modify that rate and depth of breathing for some, oops, sorry, I'm going too far. So the dorsal respiratory group, we see this in when the modified respiratory needs to happen, or the rhythm needs to be modified. It basically tells the VRG when we need a different rhythm other than 12 breaths per minute. And so this can speed up breathing, slow down breathing, and it receives influences from external sources, which we'll talk about shortly. And then finally, the PRG, the pontine respiratory group, can also modify the original rhythm. And this helps to adapt breathing to special circumstances. So when we're sleeping, exercising, vocalization, and emotional, like when we cry, the ugly cry, this PRG is helping the VRG modify that original rhythm. And that is in the pons. So how do those receptor groups get all of that information? Well, they get from 4 different types of receptors. Now, your book goes into lots of detail here, but I just want you to kind of short and sweet know the 4 different types and how and why they are important. So the first type is central chemoreceptors, and they get their information from changes of pH in the CSF, in the cerebrospinal fluid. And that reflects, first of all, you're thinking, well, what does pH of cerebrospinal fluid have to do with anything? But that pH reflects the carbon dioxide level in the blood. So remember, we talked about if carbon dioxide is building up, it can become acidic, and that's going to change the pH. So those central chemoreceptors in the brainstem, they are kind of reflecting any changes in that pH. Then next up are peripheral chemoreceptors. They're in the branches, or the large arteries above the heart, the carotid and aortic branches. And they are responding to how much oxygen and carbon dioxide is in the blood. That's an easy one. Then the stretch receptors are found in the smooth muscles of the bronchi, bronchioles, and in the pleura. And they respond to inflate the lungs. So they kind of have a separate job. They're not looking at the blood exactly, but they are going to respond to inflation of the lungs. And then the fourth one is irritant receptors. Those are nerve endings that are along the epithelial cells of the airway. And these are responding to things that are coming in from the outside world. So smoke, dust, pollen, fumes, cold air, and extra mucus that's building up in the airway. So they're triggering other reflexes, shallower breathing, holding your breath, or coughing.